Okay, on question 7. We know the distance the car accelerates plus the distance it cruises is 1,350 meters. What is the distance it accelerates in delta x1, the distance through which it accelerates, and delta t1, the time through which it accelerates? How would we write that? Pause the video and write it down. So we can write that, of course, as delta x1 equal to 1/2 a delta t1 squared. The distance through which it goes during the acceleration is simply 1/2 the acceleration times the time through which it accelerates squared. What is the distance it cruises in delta x2, the distance through which it cruises, and the cruising delta t2, the cruise time? Pause the video and write your answer down. Of course, that's delta x2 is equal to the cruising speed times delta time 2, not time 1, time 2. Okay. What do we know about the time of acceleration and the time of cruising? Pause the video and write it down. We know that the time of acceleration plus the time of cruising has to equal 60 seconds. What do we know about the distance through which we cruise, or through which the acceleration happens, and the distance through which we cruise? Pause, write it down. We know that the sum of delta x1 and delta x2 has to equal 1,350 meters. How can we write the total distance in terms of delta t1 and delta t2, the time of acceleration and the time of cruise? Pause it and write your answer down. Of course, what we have here is that 1/2 a delta t1 squared, the distance through which it accelerates, plus the cruising velocity times delta t2, the distance through which it cruises, has to sum up to 1,350 meters. Okay, starting back with this equation, 1/2 a delta t1 squared, the distance through which it accelerates, plus vc delta t2, the distance through which it cruises, has to equal 1,350 meters. What do we know about the velocity at the end of the acceleration and the beginning of the cruising? In other words, how can we calculate the velocity of the car at the end of the acceleration time? Pause it and write your answer down. Of course, what we can say is that acceleration times delta t1, the time through which the acceleration occurs, has to equal the cruising velocity vc. Now, solve for the acceleration time increment, delta t1, in terms of the vc, cruising velocity, and a, and substitute it in the first equation above, and you should obtain a quadratic in vc, which you should be able to solve.